Hello, thank you for joining us on Space Nuts, a show about astronomy, space science and stuff, all sorts of stuff. And we've got a lot of stuff to talk about today. It's a jam-packed program, and we could probably do 2 programs with this much material. And you can see how professionally I've prepared the run sheet. We're going to be looking at the Russian missile test that has certainly caused a few problems on the International Space Station. It seems every other week something's happening with the ISS. I think they probably weren't too worried about the blocked toilet problem now that this has happened. There's a new dark matter theory that's been published, and we'll talk about that. Also, the discovery of a small black hole beyond our galaxy. It's not far outside our galaxy, but it's there. What does that mean? And we're going to answer questions about, I love this one that comes from Sweden. Can we nuke Venus and reverse the runaway greenhouse effect? I hope so. Also, life on Mars. And we've received a photo from Rusty in Western Australia, which is a photo of the moon with this beautiful halo around it. And he wanted to find out, what the effect is and why. And we will use that photo on the cover of this week's episode so you can see what he's talking about. So we have plenty to talk about today on Space Nuts. I am Andrew Dunkley. I'm your host, and joining me, as always, every week is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Especially wearing my Space Nuts sweatshirt today. Look at that.
I'm wearing mine too.
Oh, ta-da!
Yay! It's just a bit colder here, so I'm wearing a jumper. It's freezing. This has got to be the coldest November I think I've ever experienced out west. So I don't know what's changed this year. Global cooling, perhaps. I don't know. It's been a very cold, wet winter and spring. So yes, hopefully we'll get some warm weather soon.
It's definitely not global cooling, Andrew.
No, definitely not. Now, let's firstly talk about this Russian missile test. It was described as an anti-satellite test, but the problem with it is it's caused some debris, which caused a little bit of a panic with the International Space Station. What happened?
So exactly as you've said, this is something we didn't expect. It was basically a surface-to-space missile, which was fired by the Russian military into one of its own satellites on Monday this week. And it was basically a test to see, I'm sure it was to see whether they could hit it, and they did. But it's been widely condemned because of the debris field that it's generated. Yes, at least 1,500 particles big enough to track, and many other smaller pieces of debris. Probably hundreds of thousands of smaller fragments, and it's really, what's bizarre about it is that the missile was aimed at a satellite that is in an orbit just a little bit higher than the International Space Station's orbit, which is about 400 kilometers above the Earth. And the expectation now is that the debris field from this spacecraft will spread out, and the space station will pass through it or near it every time it orbits, which is every 90 minutes. However, after I think they spent something like three orbits or 3 passes of the debris field, the NASA kind of mission control for the space station determined that it was safe to actually set the crew back into the main interior of the space station, because they were all sent to their lifeboat stations, yes, which are the spacecraft that are permanently docked with the space station to bring crew back home in case of an emergency like this. However, I think, as I understand it, there are still several of the modules of the space station are being sealed off. And I guess what they're doing is just shutting down the amount of volume that you need to keep a decent atmosphere in, just in case one of these modules gets hits. So if it's sealed, that's less of a problem.
That's pretty scary, Fred. And got to bear in mind that 2 of the astronauts on the ISS are Russian.
Are Russian, yes, that's right.
So I don't think there was anything malicious in it, but it's certainly drawn the wrath of the US government. They have been scathing in their criticism of this. And, I think they've got a point. Nobody knew this was coming. And it sort of beggars belief that you just go and shoot something in the sky and not think about the consequences. Maybe they did, but it's a real mystery. And, space is just going to get busier and busier. And we need to have room up there. And you don't want to really have all this junk flying around out of control and getting in the way. There was one suggestion that this could set back future space exploration or future business around the planet by many years.
Well, that's the length of time that they're talking about the orbits of these particles decaying in, years or decades. So that, they will eventually come back to Earth, because even though it's effectively a vacuum out there, there's still a little bit of atmosphere at the height of the space station. It's enough to slow down the space station, so they've got to keep boosting it up to a higher orbit. And it will eventually cause this debris field to decay. But yes, it's been, I think, greeted by all the commentators I've heard and read, but with incredulity. What on earth were they thinking of?
Yeah.
And I would imagine, and this is me now reading between the lines, but Roscosmos, the Russian space agency, are probably also saying, what on earth were you thinking of?
Yeah.
Because we get the impression...
It wasn't them.
No, it wasn't them. It was the military. Maybe, there aren't particularly good links between the two, essentially, Russian government agencies. I don't want to speculate any further than that, but it has been greeted with surprise. And we think at the moment there's no immediate threat to the astronauts on board the space station, but there could be just one of these bits of debris ploughing into, one of the modules. Punctures the space station.
What we need to do is send Sandra Bullock up there. So
yes, that's right. Yes.
Yeah, she'll sort it all out. She's pretty good at that.
Apparently.
All right. Well, we'll watch with interest. Could it mean at some stage they might have to move the space station permanently into a different orbit?
Probably not, because it's such a big object. Changing its orbit at all. And they do... Probably once or twice a year, they have to change its orbit slightly to avoid potential collision with tracked bits of debris. But to change its orbit significantly, like to put it up to 600 kilometers or something like that, that's in engineering that I think is beyond its capabilities at the moment.
Wow.
Because you'd need such a big booster rocket to do that, given the amount of material that's up there.
All right. Well, hopefully it will not become an ongoing threat, but yes, a lot of heads shaking and fingers wagging.
Yeah, exactly. That's right.
At the political level. All right. If there's more to report on that down the track, we will certainly let you know. Now, to this fascinating story, and I've read some reports to suggest that this is also a little bit scary. The discovery, publishing of a new dark matter theory. What are they proposing, Fred?
Yeah, I confess that I haven't really gone deeply into the details of this. It's a paper published in Physical Review Letters, which is a very eminent journal. And this is basically an international team of physicists from many different institutions. And it's really an addition to or a modification of dark matter theory, such as it is, because we don't know what dark matter is. It's we know it's there. We think it's some sort of subatomic particle that permeates not all of space, but it likes to be where normal matter is, and that's how galaxies don't fly apart and all the rest of it, as we've talked about many times. But this new theory suggests that dark matter actually originated in normal matter. And that's the new part of it, because the theory as it stands at the moment is that dark matter was created essentially in the Big Bang, or in the aftermath of the Big Bang. The research that's been done already all has the idea that some fraction of what was created in the Big Bang was dark matter, as part of this thing that's sometimes called a thermal bath. And it's where basically there was this, this superheated plasma, if I can put it that way, which formed dark matter particles, and that's so. The idea is, I'm sorry, I'm not making this very clear, but the idea is that dark matter came into beginning independent of normal matter, right at the beginning, right at the time when the Big Bang occurred. But the new theory, has some sort of mechanism in it that creates dark matter from normal matter. And that then begs the question, if you accept that as part of the theory, okay, so why is the universe not made completely of dark matter? Because if normal matter turns
someone would ask that question
I think
straight away.
You might have had it in the back of your mind at the beginning of this. And that clearly hasn't happened. And what they're saying is it hasn't happened because the universe went through this period in the first gazillionth of a second, which we call the inflation epoch, or the inflation period, when its size changed from being the size of a pinhead to the size of a galaxy in 10 to the minus 33 of a second. Or I can't remember the details, but it's that kind of thing. It's just mind-blowing stuff. And what they're saying is that because of that expansion, then dark matter was the process of changing normal matter into dark matter was inhibited. There was some sort of dampener put on it, and so that's why we've only got this fraction today. And of course, normal matter is completely outweighed in the universe by dark matter. We think it's about 5 to 1. The amount of dark matter compared with the amount of normal matter. So what that suggests is that much of the if this theory is correct, much of the normal matter actually became dark matter, and there's this small fraction left, this sort of 20% or thereabouts, so a bit less than 20%. That's all that's left because it wasn't turned into dark matter.
It's interesting because if they're right and that happened, it's a good thing, because if dark matter didn't come into existence at the exact same time as normal matter, then we'd have a lot of normal matter in the universe now compared to what we've got at the moment. So it might have inhibited our capacity to exist.
Indeed, it might not. Things called galaxies might not have been able to hold themselves together because this mass was not there. And of course, you could equally argue that they'd hold themselves together because there's more normal matter. Because that hasn't been turned into dark matter. Anyway, all that notwithstanding, the big question, of course, is how can you test that?
Yes.
And all they're saying is that there might be what they call an observable fingerprint, some sort of signature in that great tool of cosmologists, the cosmic microwave background radiation, the flash of the Big Bang that we can still see by looking so far out into space. You're looking back 13.8 billion years, and you see this wall of radiation which has a pattern imprinted on it, which comes from what's called the baryonic acoustic oscillations, the sound waves ricocheting through the fireball. That is what tells us about the conditions within the Big Bang. We've learned a huge amount from that in the world of cosmology and understanding the origin of the universe. Maybe there is still something else that can be teased out of it that might actually indicate that perhaps dark matter does turn into normal matter. And I can sort of imagine, the kind of thing that might be, but I can't imagine how you would go ahead and find it. It would be such a
I don't know
secret.
either, but that becomes the challenge. You come up with the theory, then you've got to prove it, but you can only prove it if you can find the evidence. And yes.
So it's an interesting one. I will actually, I haven't had time to do this, but I will go and have a look at the original paper and see if I can understand it for a start. But try and make, if there's any more comments that I can make on this, then I will do.
Yes. Once you get through the 75 pages of authors.
That's right. Absolutely. Yeah.
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 All right. There might be more to talk about in the future in regard to this theory, but yes, it looks like they're considering that dark matter became at the moment of the Big Bang, and it made itself out of normal matter.
Yeah.
Yet to be proven, but it seems to be a theory with some weight. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. 1,
3, 2, 1.
Space Nuts.
Thanks for joining us, and I hope you're well. Now, I do want to mention a couple of things. First of all, that we have a YouTube channel. If you are someone who likes YouTube, go to spacenuts.com/c/spacenuts, and that's where you'll find us. And we have all our episodes on there. And of course, in recent times, we have been providing a video version of Space Nuts on YouTube. So you can watch us as well as listen. Some of the earlier YouTube episodes are just audio, but the most recent episodes, going back a while now, are there. And we've put them in smaller chunks, so they're easier to manage. So you might find that more to your liking. If you haven't got time to sit down and listen to the whole darn thing, you can watch it in small, manageable chunks. That's on YouTube, so do a search for Space Nuts Podcast. Now, Fred, we have been talking about your new book, Space Warp, but one thing that you've released along with the book is a calendar of your sketches. Now, a few people know that you're a musician, but also an artist.
Yes, sort of. A cartoonist might be better. So, indeed, here's the calendar, Space Warp 2022, with one of my cartoons, which is meant to depict relativity there on the cover. It's the Express meets relativity. But these are drawings, as you've said, that I did for the book. Here's the what the Trojan asteroids really look like. That's. Another one from the pages of Space Warp. But this is a calendar. It's got dates in it, and also the phases of the moon, which are printed the right way up for the southern hemisphere. So I'm sorry if people in the north would like to. The right way around for the south. But
if they turn it upside down, it'll be okay.
That's pretty well right, yes. So, the calendar, I think it's about $20 Australian, which is next to nothing in US currency.
Yeah, about 10 cents.
And Hugh will, we hope, have them available. Probably what's more likely is Hugh will put a link on the Space Nuts podcast website, and you'll be able to buy them. Actually, now this is the thing. I will sign them. I'll sign every one that goes to Space Nuts listeners. So you get the artist's signature as well.
Fantastic. All right. So spacenutspodcast.com is the place to go, or spacenuts.io, and click on the shop link. If it's not there, it will be soon. So I'll chase Hugh up because he's probably on his lounge watching the Muppets or something. So that's all right.
Sorry, Hugh. Look, I apologise, Hugh, on behalf of Andrew. There, he's. It's not that. I know it's not the Muppets. It's Get Smart that you watch, isn't it?
Yeah, that's right. Exactly. Now, moving on. Our next topic is strangely about black holes. We never talk about those. But this story is interesting because they've discovered one, they believe, that's outside our Milky Way, but not by much, and it's a small one. So, what have they found? Why have they found it?
Yes, so this is... It is a black hole outside our Milky Way galaxy because it is in the Large Magellanic Cloud. The biggest of the two, the bigger of the two large dwarf galaxies that orbit our Milky Way. visible from the southern hemisphere, beautifully seen in dark regional Australian skies, as you would well know, Andrew. The Large Magellanic Cloud is about 165,000 light years away from us, from our vantage point in the outer reaches of the Milky Way. The small cloud's a bit further, about 200 light years, and not only does it look smaller because it's more distant, 200,000 light years, not only does it look smaller because it's more distant, it also is smaller than the large cloud. The large cloud is, it's measured in, I think, hundreds of millions of solar masses in terms of its mass. So a well-studied object, an irregular galaxy, does have some sort of evidence of stubby spiral arms, perhaps. But there it is in our southern skies, and it has been observed by astronomers using the European Southern Observatory's very large telescope, the VLT down there, and Serra Paranal in northern Chile. And as I always mention, because the Australian government pays me and the Australian government made this arrangement, Australian astronomers have got access to that telescope, or that set of telescopes in the strategic partnership that was signed off in 2017, and they're making very good use of it. This story, however, does not come from Australian astronomers. At least one of them is from, at least one of the astronomers responsible is from the UK, Liverpool John Moores University, Saraceno. And what they've done is they've observed one of the many clusters, young clusters of stars in the LMC, the Large Magellanic Cloud, which are a little bit different from the ones we find in our own galaxy. The clusters come in two sorts, Andrew, what are called globular clusters, which are truly ancient objects, almost the age of the universe, and things called open clusters, which are a bit like the Pleiades star cluster in our night skies, not far from Orion, part of Taurus the Bull. That is an open cluster. It's rather than being a group of 500,000 stars, it's a group of maybe 1,000 stars. That will be a fairly big one. And they still have the gas, traces of the gas in them in which these stars were formed. So they're very young. They're kind of infant star, not exactly nurseries because they're the nebulae where stars are born, but they're star kindergartens, if I can put it that way. And they've studied one of these clusters, which rejoices in the name of, where has he put it? NGC 1850. There you are. That's the cluster's name. NGC, the new general catalogue, published in, I think it was 1888. It's not new anymore, but still very useful. NGC 1850. And they've studied the stars in it and found one that has a curious motion. Basically, it's got blips in its movement, and the only interpretation that you can make of that information is that there is a black hole orbiting it, or the other way around, more likely, actually. So what you've got is a star in orbit around a black hole. It's about an 11th solar mass black hole. And the reason why it's an extraordinary discovery is, first of all, as you said, it's the first one discovered outside our galaxy, the first one of this sort, rather than being a supermassive black hole, which are often seen outside our galaxy. In fact, we think there's one at the middle of every other galaxy. But this is a stellar mass black hole, so it kind of been formed from the debris of a dead star. So it's unusual because it's outside the galaxy, but also it is very, very young. This cluster is only about 100 million years old. That's a tiny age for a cluster like this. They are, as I said, they're the stellar kindergarten regions, and 100 million years old is actually, I guess, fairly typical of an open cluster. But it's some of them are even younger. The Pleiades are even younger than that, but most of them would be maybe 500 million years or thereabouts. So this one's a young star cluster, and it is the youngest object in which a black hole has been found. That's the record that I'm trying to get to in this long-winded explanation.
Right.
As the astronomers write themselves, no black hole has ever been discovered in a cluster that young.
So the question becomes, how did that happen?
And so it's not that surprising, really, because we know that black holes come from massive stars, and the most massive stars have the shortest lives. Their lives are measured in tens of millions of years rather than billions of years, like the sun. And so, if you had a massive star in this star nursery when it was being formed, it may well have gone through its short life very quickly, burned up its hydrogen fuel, and basically collapsed as a supernova. The core forms a black hole, and what you've got is this orbiting pair, which we wouldn't know about. The interesting thing is we wouldn't know about this black hole were it not in orbit around another star, or the other way around, in fact. And if you remember, there's been a number of stories that we've covered recently that are similar to that. People finding black holes not by the fact that they've got an accretion disk of stuff swirling around them that's being gobbled up by the black hole and releasing X-rays and radio waves, but by the fact that it's pulling another star out of kilter, if I put it that way. But this is the first time a discovery like that's been made beyond our own galaxy. It's extraordinarily good research. Yeah,
and I suppose that opens the way for perhaps finding more through various methods. But the European Southern Observatory's got the credit for this one, which is fantastic. But I mean, it's always exciting to find something new, always. And it looks like they've kind of stumbled across it, but it's there. We know they exist, and finding more probably becomes more apparent now because you found a methodology, and there's all sorts of possibilities that come up. You said that the biggest black holes are caused by the most massive stars, and because they have the shortest lives. The same thing applies to rock and roll stars. The most massive rock and roll stars have the shortest lives too, I've noticed.
It's a very good parallel, yes. Probably similar physics involved as well.
Possibly so, yeah. They implode.
Yeah, that's right.
Yeah, all right. Well, there might be more on this one as well. So a couple of stories that have come up that we may well be able to follow up on future episodes of Space Nuts.
Indeed.
You're with Andrew Dunkley and, of course, Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.